right, so lesson 3.7, we are going to dive in and look at how logarithms can be used to solve exponential equations. So I want to start with the example here, and I want to make sure it's very clear. Logarithms are needed when we need to find a missing exponent. And that is exactly what is happening in this problem. Now, the part that's holding the exponent, we call this 1/2 the base. There's a number in front of it. So what we want to do is we want to get rid of anything that is not attached to the base. And that is going to be done by dividing by 24. So we are going to have 1/2 to the power of x equals 6 divided by 24. Now, if you wanted to, you could reduce that to 1/4. Some of you can probably solve this equation with mental math because it's not real hard to figure out 1/2 to what power equals 1/4, but some of you may not, okay? Now, let me be clear that sometimes these equations are not things that you can solve in your head easily like you can here. So I would like to show you a process where we can use logarithms to help us solve, okay? So here's what you're going to do. You are going to apply a logarithm to both sides of the equation. Kind of like this. You're just throwing a logarithm in front of each side of the equation. Okay? Now, what that allows you to do is that allows you to now use logarithm properties. There's a property that says any exponent that's attached to a logarithm can be moved to the front. So we will move this x to the front, which it would be like x times log 1/2. And now that the x is not in the exponent anymore, what you can do is divide by log 1/2. And then use your calculator to do the rest. So we want log 1/4 divided by log 1/2. Again, type all this into your calculator and you would get 2. Let's try another one. So we've got e to the x equals 2 to the 1 plus x. Same situation where we want to find a missing exponent, so we need logarithms to help us here. So we're going to apply a logarithm to the front of each side of our equation. Okay, now I'm going to make an adjustment. I can use a logarithm, but I think what would be better suited here is a natural logarithm. The reason why I think that would be a better choice in this problem is because this problem has an e, and ln and e are inverses of each other. So if we use a natural logarithm, it's going to set us up to be in a better position. Okay, so once you have your logarithm or your ln on both sides, you're going to apply properties. And those properties, again, tell us that we're allowed to take anything that's an exponent and move it to the front as multiplication. Ln of e cancels because it equals 1, so you can get that out of there. And then ln of 2 is something that can be done in the calculator. I'm not going to do it just yet. What I'm going to do is I'm going to distribute ln of 2. And now I'm going to grab my calculator and figure out what that value is. So ln of 2 is 0.693. So this would be like 0.693x. Now it's kind of hard to tell, but you do have like terms here. You have x's on both sides. So your next step would be to put all the x's on one side. And so we would have 1 minus 0.693, which is 0.307. And then we would just need to divide and we would be done. So I know all the decimals on this problem make it a little bit overwhelming. Try not to get too overwhelmed by the decimals and just think about the fact that you have a calculator that will be available to you to make this a little bit easier. So final answer would be 2.257.
And I need you to call 2102 to study 2102.
Okay, couple review questions. So we have logarithms on both sides. We've seen problems like this before, but let's review what to do. So I have two logarithms here. They're both natural logarithms, but that doesn't matter. There are properties that allow me to take those two logarithms and condense them into one. So what I would need to do is, because of the plus sign, I would be able to condense it into one logarithm with multiplication in between. I also, on this other side, have a number in front, and because this is a logarithm, I am allowed to move that back as an exponent. So that's what we would do to start. After that, we would say, okay, this is awesome because there's a log on both sides and they cancel each other out. And that leaves you with everything that's on the inside. Okay, now from this point on, I'm just going to stop and I'm not going to finish this problem because I'm not going to make you do any of these quadratic logarithm equations. So I wanted to just show you just purely how to set this up with the understanding that you won't have to do anything quite this complicated on the homework. Okay, let's do one more like that. So again, I'm going to start here on the left and I'm going to rewrite this as a single logarithm. So that's going to look like x times x minus 8. By the way, I know it's multiplication here because of the plus sign. Now this time I don't have a log on both sides. So what I would need to do next is I would need to do rewrite as an exponential equation. So I'm going to say 3 to the second power is equal to all the stuff inside the logarithm. 3 to the second power is 9. I think I'll go ahead and distribute the x through. And then this would be one, again, where you would need to use factoring to help you solve. So I would subtract 9 to put all the stuff on one side. And then to factor, your thought process, remember, is what times what equals 9, that adds up to 8, or negative 9, that adds up to negative 8. Negative 9 plus 1 would do that. So your answer would be negative 1 and positive 9. Here's an example of what Delta Math may ask you. So Delta Math, what we're going to do is isolate the exponential part. So dividing by 48 would be your first step. And you get 2 to the x over 3 power equals 1. From this point, you can apply a logarithm to both sides of the equation. And it wouldn't matter if you did a log or a natural log. It doesn't matter in this situation. I'm going to put a log right here in front of my 1. And applying that logarithm allows me to take my power and move it to the front. So what do I have? I have x over 3 log 2 equals log 1. Okay, what you'd want to do next is probably get rid of log 2 so that you can get closer to the x variable. So x over 3 is equal to log 1 over log 2. You're going to just use your calculator to help you there. So log 1 divided by log 2 is 0 because log of 1 is 0. And then you would multiply by 3. And you would still have x equals 0. Okay, let's do another one like that. Again, I want to try to get to the exponential part, so I want to divide by 8 right from the beginning. And that gives me e to the x over 2 is equal to 1/8. From this point, we're going to apply a logarithm to both sides. But I think the smartest thing to do is, because we have that e, would be to use ln. Right? Anytime you have e and ln kind of go hand in hand. It's going to make your life easier to use that. Okay, now that you have a logarithm, you can apply logarithm properties, which allow you to move things to the front, exponents to the front, I should say. So I have ln of e. Remember, ln of e cancels each other out and just leaves you with 1. So really, you just have x over 2 equals ln of 1/8. Ln of 1/8 is something you can type into your calculator. So let's see, log of 1/8 is negative 2.0794. And then we need to multiply to finish this problem. So we're going to multiply that answer by 2 and get x equals negative 4.16. It says round to the nearest 100. Okay. I think I'll skip and go to this one. So next one, we've got our last problem. We have just more steps at the beginning. Like I need this 8 to be over here. I need this 4 to be out of the way. Basically, you're working your way towards the exponent by getting rid of all these other numbers. One thing I'm not going to do is I'm not going to divide 11 by 4 because I know it doesn't come out even, and I don't want my answer to be rounded yet because I'm not done with the problem. So this is good for now. Now I'm going to apply a logarithm to both sides. So let me move this out of the way and put a log here in front. And I want to do a logarithm on both sides because I really need this thing here to be moved. So we have log of 11 over 4 is equal to 5x times log of 3. Now I'm trying to solve for x, so I think it makes sense to divide this log of 3. So this is going to leave me with 5x equals, actually I'm going to go to my calculator now. Log of 11/4 divided by log of 3 is 0.920799. Divide that by 5 because we need to get rid of this 5 out here. And we're rounding to the nearest tenth. So this answer is 0.184, but I need to round to the nearest tenth, so it'd be 0.2.